We are moving on to chapter 9, and we're going to be looking at estimating the value of a parameter. So remember vocab from the beginning of the year. A parameter is a measurement taken on a population. So in this chapter, what we're going to be looking at doing is taking our sample and finding our statistic, our measurement that we can take on a sample, and then using that to estimate what it would be on the whole population if we would have been able to actually collect data from the whole population. So in our first section, we're going to be looking at estimating a population proportion. So we're going to find a point estimate, and we're going to talk about how to construct and interpret a confidence interval, and then how to determine what sample size we would need if we know how much error we want to allow ourselves. So a point estimate is the value of a statistic that estimates the value of a parameter. So again, remember that early in the year vocab. So a statistic is taken on a sample and a parameter is taken on the population. So if we sample n number of individuals and ask them a yes or no question, or try to determine whether they have or do not have a certain characteristic. So this is not an average. It's not looking at values of that. It's either a yes or a no. They have it or they don't. They agree or they don't. And X is the number of individuals that have the characteristic. So we can then estimate what we call our p hat, which is the proportion in the sample that has a certain characteristic. Now, if we have sampled well, ideally that would be close to the actual proportion for the whole population, but probably not perfect. So, in this example, in July of 2008, a university poll asked 1,783 registered voters nationwide whether they favored or opposed the death penalty for persons convicted of murder. 1,123 were in favor. So if we want to find a point estimate from this sample, so we can find the statistic proportion in this sample, and then we're going to use that as a point estimate for the parameter in the population. So what we want to do is take what number have the characteristic, in this case the characteristic is in favor of the death penalty, and divide that by how many were sampled. So 1123 over 1783, 0.63. So from this, in the sample, 63% were in favor of the death penalty. Now if we have sampled well, we would hope that that is close to what it would be in the whole population. So this is our point estimate for the proportion of people in the whole population nationwide that are in favor of the death penalty for people convicted of murder. Now, the population measurement should be close to that point estimate, but probably not perfect. It could give a little either way. And so what we're going to do is create what's called a confidence interval. A confidence interval takes that point estimate and it gives it a little bit of error. So a confidence interval for that unknown parameter consists of an interval of numbers. The point estimate is going to be right in the middle, and then we're going to widen out and say, but it's probably between here and here. The way we do that is first we have to determine what's called our level of confidence. Our level of confidence represents the expected proportion of intervals that will contain the parameter if a larger number of different samples is obtained. The level of confidence is denoted as 1 minus A times 100%. So typically we think about being 90, 95, or 99% confident. Now, the idea of confidence intervals is very misunderstood by the public in general and by students early on in statistics. So hopefully we can get this straight. If I say that I am 95% confident, I have a 95% confidence interval. What that means is if I did this sampling 100 times, 95 of them would have the right value in it. 5 of them don't. That means the one that I'm reporting might be one of those 5. Okay? So that's the idea of confidence, is if I do a 95% confidence, I know that if I had actually done this 100 times, 5 of them are going to be wrong, and this might be one of those 5. If I have a 90% confidence, 10 of them are going to be wrong, and this might be one of those 10. I don't know. We have no way of knowing. So that's the idea of what a confidence interval is. And again, the popular numbers we use are a 90, a 95, and a 99%. And that is according to that 1 minus a times alpha. So if I say I'm 90% confident, my alpha is 0.1. Think of it as like the complement. Okay? If I'm 95% confident, my alpha is 0.05, the rest of the 95%. And if I'm 99%, then my alpha is 0.01. So for a 95% level of confidence, this kind of goes through the same thing that I just talked about. That's our alpha 0.05, because those, think of them like complements. It implies that if 100 different confidence intervals were constructed, each based on a different sample from the same population, 95% or 95 out of those 100 are going to contain the right parameter. 5 of them don't. And we have no way of knowing whether ours is one of the 95 or one of the 5. Okay? So to construct a confidence interval, what we do is we start with that point estimate, and then we're going to add and subtract our margin of error. Okay? Our margin of error in a confidence interval is an estimate of a parameter, measures how accurate the point estimate is. So 3 things affect the margin of error. The first thing is our level of confidence. So 90, 95, 99, again, the common numbers. As the level of confidence increases, the margin of error also increases. So let's say that I have this interval, it's this big, right? And I'm 95% sure. I got my 95% confidence on this. Well, if I want to be 99% confident, well, that would mean that instead of having 5 of them that could be wrong, only 1 of them could be wrong. I'm going to need to give myself more wiggle room. So as we become more confident, our interval has to widen up, which means our margin of error is bigger also. The sample size. As the sample size of increases, as the random sample increases, the margin of error decreases. The more people we ask, the more sure we can be about this. So if I ask 100 people, I'm this sure. If I ask 1,000 people, I'm feeling better about this, right? I can be more confident because I talk to more people, a bigger portion of my population. And the other thing is the standard deviation of the population. This one we can't really choose to adjust. So the more spread there is in a population, the wider the interval is going to have to be to cover that spread. The other 2 we can control. We can decide how confident we want to be, and we can decide how big of a sample we want to take. The standard deviation of the population, we can't really control that one. But as the standard deviation is larger, there's more spread in the population, there's going to have to be more spread in the interval as well. So to think about that standard deviation, we're going to use this formula. Probably want to write this down somewhere. So the standard deviation is going to be equal to the square root of p times 1 minus p. That's our point estimate. That p is our point estimate. So p times 1 minus p divided by n, and take a square root of that. And that works as long as n, our sample size, times p times 1 minus p is more than 10. Okay? And we had that same requirement that we already talked about in the last chapter. So this is not really new information here, but that same requirement again. All right, so our confidence interval indicates that 1 minus alpha times 100, so 90, 95, 100, of all simple random samples of size n from the population whose parameter is unknown will result in an interval that contains that parameter. Yes, this is repeating. It's the same thing, again, because, like I said, students, early on in statistics, and the general population doesn't really understand this idea of a confidence interval. It doesn't mean like I'm 95% sure I did it right. We're always sure we did it right, hopefully. But what we're unsure about is whether this was one of the lucky ones or the unlucky ones. And that has nothing to do with whether we did it right or not. So when we say we're 95% confident, it's not like, yeah, I'm 95% sure I did it right. It's if I redid this 100 times, 5 of them are going to be wrong, and I only did it once, so this might be one of those wrong ones. I just don't know. All right, so these are the formulas that we would use to find the confidence interval by hand. We're not going to do that, but we're going to go ahead and take a look at these formulas. So what we do is we start out with p hat. That's that point estimate. That's that success divided by sample size. So we start out with that p hat. Then we're going to add and subtract from that z measured at alpha over 2. So alpha, remember, is the complement to our confidence. So if I'm 90% confident, alpha is 0.1. Divide that by 2, so that'd be 0.05. And then z, remember those z tables, those normal distribution tables. I was struggling for the word there. Those normal distribution tables that we looked at earlier this semester and found those z-scores, that's what that is. So we're taking that z-score, that normal distribution number, and multiplying it by, maybe that's a little familiar there, that square root and the p and the 1 minus p and the n, that's the standard deviation. So we take the z, the normal distribution number, times the standard deviation, and then we add and subtract that to our point estimate. Okay? So we'll look at how StatCrunch can actually come up with these answers for us, though, because looking all those up on the table and doing these calculations is pretty tedious by hand, and so we'll use the technology for it. But I want you to understand how these are constructed, and some of your problems will actually ask you a little bit, too, about how they're constructed. So our margin of error, then, is that piece that's being added to and subtracted from our point estimate. So on both of these, notice we have that p hat plus and minus, then this other part, the z times that standard deviation. That z times the standard deviation piece, that is our margin of error. That's what we're adding and subtracting to the point estimate. So we start at our point estimate, we add and we subtract the same amount, and that gives us our interval. And that amount that we're adding and subtracting is called our margin of error. All right, so back to the same example. Now what we want to do is, in our first time we looked at this example, we found what the point estimate was, 63%. Now what we want to do is find a 90% confidence interval. Okay, so we know that in our sample, it was 63% said yes, death penalty. Now if we had sampled the whole of the population, what do we think that the proportion may have been? Okay, so we're going to give ourselves some wiggle room. 63% we think is a good estimate, but probably not perfect, so we're going to give ourselves some wiggle room. Okay, 90% confidence interval. All right, so let's look at how to do this in StatCrunch. So in StatCrunch, you're going to go into Stat, and we're going to go to Proportion Stats, because that's what we're measuring here and trying to calculate is a proportion. We only have one sample. We only did this once. We're not comparing two different groups. We just have one group, so one sample. And what we have is a summary. We don't have data. Data would be person number 1, yes. Person number 2, yes. Person number 3, no. We don't have that. We don't have a list of all the data. We have a summary. We just know how many people said yes. So we're going to choose with summary. Our number of successes, in this case, that's the number of people that said yes, death penalty. That was 1123. Out of our number of observations, that's how many people were in the sample, which I wrote down in my teaching notes here, 1783, because I know I would forget that. Now what we're doing is a confidence interval. This part, this hypothesis testing, we'll come back to that in a later chapter, but right now we're talking about this confidence interval thing. Our level is 90% because that's what the problem asks for. So it could ask for 90, 95, 99. It could ask for something else, but those are typically the 3 that we work with. And then I'm going to compute. Okay, so now what it gives us is our count and our total. So it's giving us back what we entered in so that we can kind of double check it. This sample proportion right here, that's that 0.63. So it's giving us our p hat value as well. So we had already calculated that earlier, but then it's giving us that. And then this lower and upper limit, those are our confidence interval values. So our confidence interval would be 0.61 to 0.65. So our sample, 0.63. Whole population, probably 61 to 65%. 90% sure. 90% confidence. If we did this 100 times, 90 of them are going to have the right answer. We're hoping this is one of those 90, that the actual is somewhere between 61 and 65%. Okay, so this lower limit, upper limit, those are the two numbers for the confidence interval. So now, on that, what if the problem asked, what is the margin of error? Well, the margin of error is when we take that point estimate, how much do we add and subtract? And it should be the same. So if 0.63 is the middle of the interval, and our interval is 6.1 to 6.5, well, 6.3 to 6.1, that's a difference of 2. Also, 6.3 to 6.5, that's a difference of 2. So our margin of error is 2%, 0.02. Okay? The margin of error is how much do we add and how much do we subtract from that point estimate to get those upper and lower limits. Okay? So that is the margin of error, if your questions ask about that, which some of them will. All right. Back to the show. All right. So then this is how we would calculate that by hand. Again, not gonna do that. Okay, so 90% confident that the proportion of registered voters who are in favor of the death penalty for those convicted of murders between 0.61 and 0.65. All right, so now what we want to do is figure out how big of a sample do we need. This is an ugly formula. So the number that we need in our sample, that's the n. We got to take our p hat, our point estimate, times 1 minus the p hat, the complement. Then we got to take that z, that's from that normal distribution table, divide it by e, our margin of error. We've decided that. How much error do we want to allow ourselves? We got to square that. Oh man. Okay, so that's messy. We have two possible solutions that we can work with. One is if we already have a point estimate based on an earlier study. So if we already have a good idea about what the point estimate is, we're going to use that. If we have no idea what the point estimate is, because this is the first time this thing has ever been thought about, then we're just going to have to use 0.5 and say it's a 50-50. So let's look at our example. Here we go, because we're not going to do it with those formulas. We'll use StatCrunch. So a sociologist wanted to determine the percentage of residents of America that speak only English at home. What sample size should be obtained if she wishes her estimate to be within 3 percentage points. So that's our margin of error. We have our estimate, 3 this way, 3 this way. That's our margin of error. She's going to use 90% confidence. And she has some background information on this from the census in 2000, 82.4%. So that's her kind of starting guess. So we don't need to use that 50-50 because she has a starting guess. So we're going to go into StatCrunch. All right, for this, we're going to go into Stat, Proportions, because we're still talking about proportions. We still only have one sample. Now what we want to do is figure out our width sample size. So it can be used to find the width or the sample size. We're going to use it to find the sample size with the width or the margin of error. That's what we have here is a width or a margin of error. So confidence level, it said she wanted to use 90% confidence. The target proportion is, this is where we would say 50-50 if we have no idea, but she has some idea. The last time this was studied, it was 82.4%. So we're going to start with that assumption. Now our width, it said she wanted 3% margin of error. That means it could go 3% this way, it could go 3% this way. So the width then is not 3%, but it's 6%. That's really important. A lot of students get this wrong on their homework because they just try to use that margin of error. The width is not the margin of error. It's margin of error plus and minus, so it's double that margin of error gives you the width of the interval. Now when I do compute, it tells me she's going to have to sample 436 people. If she samples 436 people, then she's going to have a margin of error that's within 3% in each direction. Okay? All right. And just pop back over to our show here. And in their calculations, they got 436.04, and so they rounded up to 437 just to be really sure that it was going to fall into that right range. And that is the end. So, as always, ask me questions as you have them. I am happy to help in any way that I can.